All right. Hello, everyone. I am Bikes Jozizu. I'm a PhD student at the Department of Geography and Environment, UNC Chapel Hill. My research is about assessing the annual soil loss in Phewa Lake watershed of Nepal using the revised universal soil loss equation. I did this research as a class project for my GIS programming class, and I did the calculation using Python language. So soil erosion is a global environmental challenge leading to uh, land degradation, uh, decrease in agricultural productivity, and sedimentation to the water resources. Understanding and quantifying soil erosion is essential for sustainable land management and conservation of water resources. So this study aims to assess the annual soil loss using the revised universal soil loss equation. So is it not working? Okay, sorry. Uh, So, what is soil erosion? It is the process of detachment, transportation, and deposition of surface soil particles from one place to the other. Um, it is primarily caused by wind and water, with water being the dominant factor in most of the landscapes. Globally, soil erosion is a severe problem affecting uh, natural resources, agriculture, and water quality. Uh, the average worldwide soil erosion rate is estimated to be around 12 to 15 tons per hectare per year, meaning that every year nearly 0.9 to 0.95 millimeter of the topsoil uh, is lost. So about 1.6% of the world's soil area is affected by water erosion, out of which 44% suffer from deforestation, 29% suffer from overgrazing, 24% from improper management of agricultural land, and 4% from the overexploitation of natural resources. In Nepal, 3.16 million hectares, which is about 11.81% of the total land area, have been affected by soil erosion, which include 38% of the forest land, 37% of the pasture land, and 10% of the agricultural land. So, Phewa watershed lies in Nepal and covers an area of 121 square kilometers. It is a typical mountainous watershed ranging from 759 to 2,481 meters elevation. It is also one of the wettest region of Nepal, receiving an average rainfall of above 3,900 millimeter. Uh, the Phewa Lake, which is included in the watershed, is important locally as well as internationally. The lake provides significant ecosystem services such as tourism and recreation, hydroelectricity, irrigation, and fisheries, whereas the lake or the watershed has also been declared as a Ramsar site, which is a wetland site for its biodiversity protection and agricultural resources preservation. However, the uh, uh, watershed ecosystem has been degrading due to number of factors such as erosion and sedimentation, waste and sewage disposal, infrastructure development, landslide, river course alteration, and encroachment, which is leading to declining in the water quality of the lake, as well as shrinking in the lake area as well as the volume. So, to quantify soil loss, researchers have developed several empirical as well as process-based model, such as SWAT, which is Soil and Water Assessment Tool, WEPP, Water Erosion Prediction Project Model, and Universal Soil Loss Equation. The process-based model like SWAT and WEPP, they require intensive calibration, uh, detailed field data, and multiple parameter, which make them complex and inaccessible for rapid assessment. Whereas the empirical models such as revised universal soil dust equation, they are relatively simpler and uh, can estimate soil erosion over a large area. Uh, the revised universal soil dust equation, it is a modified form of universal soil dust equation where the factors have been modified for better accuracy. It calculates soil erosion or soil loss based on 5 factors, which are rainfall erosivity, uh, soil erodibility, slope steepness and slope length and steepness, cover management, and practice support factors. So the first factor are rainfall erosivity factor. It is the effect of rainfall on soil erosion. It is defined as the product of total kinetic energy multiplied by the maximum 30-minute rainfall intensity. It can be calculated using different empirical equations. So the one that I used is by Renard and Freeman 1994 for the calculation of R factor. So soil erodibility factor or K factor, it is the influence of soil properties on soil susceptibility to erosion. Uh, the higher K value represent higher susceptibility to erosion, and it depends on the soil texture, such as the percentage of sand, silt, and clay, and soil organic carbon content. So the next factor, LS factor, it is the impact of slope length and steepness on soil erosion. Uh, the other factors are like C factor and P factor. This cover management factor, it is defined as the ratio of soil erosion from a field that has a particular cover and management to the field that has that is completely tilled and fallow. And the support practice factor, it is the ratio of erosion from a field with a particular soil conservation measure to the field that is that has no soil conservation practice. So the C factor and P factor, they depend on the land use type, and their value ranges from 0 to 1, and the higher value represent higher susceptibility to erosion. So the moving on to the results, the annual soil loss of Phewa watershed range from 0 degree to 1,458 tons per hectare, and the average annual soil loss rate was 15.17 tons per hectare per year, and the total soil loss was 182,275 tons per year. So on the erosion rate was classified into 5 classes based on the erosion rate, and then it showed that around 47% of the watershed have a very low erosion rate with less than 2 tons per hectare per year, whereas 17% of the watershed have more than 25 tons per hectare per year of soil erosion. Also, the result revealed that the soil erosion was more severe on the northern slope of the watershed, where there is extensive agricultural land cover and steeper slopes, whereas on the southern slopes there is high percentage of forest cover and the erosion rate was less. Also, the land use specific analysis showed that the agricultural land has highest soil erosion rate at 41.05 tons per hectare, followed by the degraded land, and the forest land has the lowest soil erosion rate. Mm, the agricultural land alone contributed to the 85% of the total erosion, despite covering only about 40% of the watershed area, which indicates that they were the primary source of erosion in the watershed. And forest watershed, despite covering 50% of the watershed, only accounted for the 13% of the total soil erosion. And the soil erosion from other land uses such as urban or grassland and degraded area were not very significant due to their less spatial extent. Moving on to conclusion, the RUSLE model integrated with GIS and remote sensing can be used effectively to quantify soil loss. It is an empirical equation and it is computationally simpler. The total soil loss of the watershed was 182,275 tons per year, with an average of 15.17 tons per hectare per year. The agricultural land was the primary source of soil erosion in the watershed, accounting for 85% of the total soil loss. The soil loss was higher in northern region of the watershed due to its intensive steep slopes and inadequate soil conservation measures. So the effective land management strategies are crucial to mitigate soil erosion and sustain agricultural productivity and preservation of the Phewa Lake. Thank you. Any questions? Yes.
When you were researching this region, and were looking at like the agricultural practices, is there any, like I'm more familiar with like agricultural practices in this area, like crop rotation and things like that. Are they doing specific like practices that are like localized to Nepal that are putting their
It
soil
is,
loss into
yeah.
perspective?
So in this part of the region, the agriculture is mostly like terrace farming. So these are like slope areas, and then the agricultural land are mainly on the northern slope. That is like a south-facing slope where there is more sunlight than in the northern slopes. Yes.
In your model, can you predict like after another 20 years what's going to happen
Um,
to this area?
yeah, but yeah, we can. I think we can do that if we have like a prediction of the land use for future land use prediction. Then we can also like run this for our future land use, and also we need to have like a future climatic prediction, like rainfall prediction, and as well as land use prediction to predict for the future soil loss.
Another question, if you move from one like basin from this lake to another one, how hard is to adjust your model to apply the same model to another basin?
Um, I think yeah we can we apply this model for another area as well. We might need to change some parameters like the cover management and support practice, and also like the equation for LS and R and K might be different for other part of the other reasons.
Thank you.
Yes.
Would you have any general recommendations to people who are working the land in that, agricultural people, farmers who are working the land there to change their agricultural practices to reduce the soil loss?
Uh,
Like any specific strategies or anything?
yeah. So the major reason for um, major reason for erosion from agricultural land is the tillage of the land as well as the crop agricultural land. They are seasonal, and only during the growing season there is a uh, crop cover, and during the other part of the year, the agricultural land are usually like fallow and uncultivated. So the one of the best reason would be like crop rotation, as well as and then better management of terraces and other like soil conservation measures, and as well as no tillage on like a steep slope would be a good strategy to mitigate soil erosion. Yes.
For your, you said that you did some Python scripting. What particular modules did you utilize for your analysis?
I used ArcPy library, and then these are the I use this formula. I developed this. I included this formula in the script, and then calculated the soil erosion. This is like the my workflow of the model. Yes.
How is the soil erodibility factor measured? The
K factor, if it can be done on the field using like a making a particular plot of land and then measuring the soil loss from the land. The one that I used is I used this empirical equation, which is based on the soil, which is based on the percentage of sand and sleet and clay on the soil and the soil organic matter content.
So could you apply a similar K factor with the like soil like classification to another part? Like you were saying, you might have to change some of the K factor calculations if you were to move this project to another watershed. Could you use a similar equation with soil composition for that?
Yeah, mainly these are like an empirical equation. So one of the major limitation of this equation is that is its applicability to particular region, which needs to be studied. So yeah. Thank you.